Okay, so the third lesson of this chapter is converting between the two systems, between the metric and the imperial system. So you're going to use your formula sheet for sure for this part. So you're going to want to have it out. Remember that we're going to have a quiz on chapter 1 on Tuesday. We're also starting chapter 2 on Tuesday. And then after chapter 2, we'll do chapter 3. And then that'll be our last unit exam, and then we'll spend some time reviewing for your final exam, which has yet to be scheduled. But as soon as I know when it is, I'll make sure that you know. 33, I think. 32. All right, so converting between the two systems. This first question asks us to measure the side length of the paper envelope of a standard CD. We have an inches ruler there, so we're going to measure it in inches. So the ruler's already kind of set there. And it looks like it is 5 inches long. Then it wants us to state or find the length in centimeters. So this is where we use our formula sheet. And the very first thing we see is that 1 inch is equal to 2.54 centimeters. In this case, we have 5 inches, so we're going to multiply 5 by 2.54. Each inch is 2.54 centimeters. In this case, we have 5 inches, so it's 5 times 2.54. Which is 12.7 centimeters. So in many cases, when you're converting between two systems, it's as simple as looking on the formula sheet, finding what the right scale factor is, if you want to call it that, and then just multiplying. Many of them are that simple to convert between the two systems. Right, so this next one, we want to measure the height in centimeters and then convert that to inches. So if we look at this, it is exactly 4 centimeters high. And we want to convert that into inches. So back to the formula sheet we go. And notice it says that 1 centimeter is 0.3937 inches. So if we have 4 centimeters, we'll multiply 4 by 0.3937. So go to the calculator and do that. So approximately 1.57 inches. I rounded it to 2 decimal places. Didn't tell what to round it to, so I chose and I did it to 2 decimal places. All right, so again, look on the formula sheet, see what the conversion is, and then multiply. In many cases, they're that simple. All right, so we've got some conversions there. I think these are all on the formula sheet, so that's what you're going to be using. So let's look at this next example. Researchers at the Harvard Smithsonian Center for Astrophysics made an announcement in January of 2001. They stated that they had frozen light by using supercooled vapor to slow the speed of light waves to 0. The speed of light in a vacuum is defined as 299,792,458 meters per second. We want to estimate the speed of light in miles per second. So essentially, we got to go from meters to miles. If we look on our formula sheet, there is no conversion between meters and miles. There's conversions between kilometers and miles, but not meters and miles. So we're going to have to first convert this into kilometers. That'll be our first step. And you might remember from the metric staircase, there are 1,000 meters in a kilometer. To go from meters up to kilometers, you have to divide by 10 every step. And because there are 3 steps between meters and kilometers, you'd have to divide by 10 cubed. So this is how we start this. We'll take the number of meters per second and divide by 10 cubed. Which is the same as dividing by 1,000. There's 3 zeros there, so the decimal is going to move 3 to the left. Your answer must get smaller. 299,792.458 kilometers per hour. And now that we have it in kilometers per hour, we can convert to miles per hour. If we look at our formula sheet, to go from kilometers to miles, the conversion is 0.6214. You're going to multiply the kilometers by 0.6214, to convert to miles. So that's what we'll do. We'll multiply that by 0.6214, and this will give us our answer in miles per hour. Okay, you guys just start coming to class on time. It's every day now, so it's going to stop, okay? So 299,792.458 times 0.6214. And so there's our answer in miles per hour, 186,291, approximately 186,291. And that'll be in miles per hour. So again, just using the number on the conversion. B says predict whether the actual speed of light is greater than your estimate. Now, I guess part A, actually, we've done part C actually. Part A asks us to estimate. And so you'd have to do some rounding there. You would probably round the 299 million off to 300 million. And then convert that into kilometers, which would be 300,000 kilometers. And then you, instead of multiplying by 0.6214, you'd multiply by 0.6. Okay, and 3 times 6 is 18, so 300,000 times 0.6 would be 180,000. That would be the estimate. We've actually gone straight to part C, which was calculate the answer to the nearest mile per second, which is what we did. So I did put mile per hour there. Should be miles per second. So let's fix that. Okay. Number 2, your class needs to lay mats on the gymnasium floor for a gymnastics meet. The gym floor measures 84 feet by 50 feet. A scale drawing of one mat is shown, and the scale is 1 to 30.5. So that means the actual dimensions of the mat are 30.5 times what these dimensions are of the picture. A classmate thinks that 131 mats are needed. Do you agree? Explain. So we're going to calculate how many mats would be required to cover that gym floor that measures 84 feet by 50 feet. And so we would start by taking a ruler and measuring the length and the width of the picture of the mat. And those dimensions are there for us. So those are the dimensions of the picture. Our scale is 1 to 30.5, which again means that the actual dimensions are 30.5 times Sal, 30.5 times what they are in the picture. So we need to take those two values and multiply by 30.5. That's where we'll start. So 1 9/16. Whoa. Try that again. Hmm. That's really weird. Try changing color. Same thing's happening. Okay. I'm going to save this. I'm going to open a different one and then go back to that and see if it works properly. Okay. Let's shut it right down and reopen. Why have that open? Technology is wonderful when it works, and it usually does, but there we go. Okay, there we go. 1 9/16. If we would change to an improper fraction, 16 times 1 is 16, plus 9 is 25 over 16. And our scale factor is 1 to 30.5, which means we're going to multiply that by 30.5 over 1. So, top times top, bottom times bottom. So on top, it's 25 times 30.5. Which is 762.5 over 16 times 1. And let's see what we get when we divide those. So 47.65625. I'm going to store that into memory slot A, because I'm probably going to need it again. 47.65625. So that's how many inches wide the mats actually are. Okay, Cheney? Are you with us? So now the length of it is 3 1/16 of an inch. If we write that as an improper fraction, 16 times 3 is 48, plus 1 is 49 over 16. And again, that's multiplied by 30.5 over 1. So 49 on top times 30.5 is 1494.5 over 1 times 16. So we'll divide again. 93.40625, which I'm going to store into memory slot B. 93.40625 inches. So that's the actual width of each of those mats. Now, the dimensions of the floor are actually in feet. So we can either convert those dimensions into inches and do it that way, or we can convert the ones that we just found into feet and do it that way. So I'm going to choose to do that. I could have gone the other way as well, but I'm just going to choose to take these dimensions that we just calculated and figure them out in feet by dividing by 12, because there's 12 inches in every foot. So that will round to 7.78 approximately, but I'm going to now store this into memory slot B. 7.78 feet approximately. So that's the actual width of the mat in feet. And now I'll do the same thing with the height, which is what I put in alpha A. I'm going to divide that by 12 to convert that into feet. And so this is 3.97 feet approximately. And I'm going to store that number now into alpha A, 3.97 approximately feet. So these are the dimensions of the mats in feet. So to find the area of the mats, or of each individual mat, we will multiply these. 3.97 feet times 7.78 feet. So again, these numbers are in the calculator in memory slot A and B. So I can take the number in memory slot A and I can multiply it by the number in memory slot B. And so each mat is approximately 30.91 square feet. That's the approximate area of each mat. Now, again, the gym floor measures 84 by 50 feet. So before I calculate that area, I'm going to store this number into memory slot C for now. My gym floor, the area of the floor, would be found by multiplying 84 feet by 50 feet. This is the entire area that needs to be covered. 84 times 50 of 4,200 square feet. So then to find out how many mats would be required, we would divide those two numbers. The number of required mats would be found by dividing those numbers together. Dividing those numbers, I should say. They need to cover 4,200 square feet altogether. Each mat covers approximately 30.91 square feet. If we divide them, that'll tell us how many mats are required. So that 4,200 divided by the number we put in memory slot C, try that again, approximately 136 mats would be required. So the student thought 131 mats are needed. That's not going to be enough. Okay, 136 mats are required. So yeah, the student's off by a little bit. Okay, student's off by a little bit. So this question didn't involve converting between the two systems because we measured the mat in inches, so then we were able to continue on in the imperial system. Looking on the next page, it says how many paving stones measuring 7.5 inches by 7.5 inches are needed to cover an area that is 1 yard by 1 yard. So we're working within the imperial system for this one exclusively. We don't have to convert between the two, but we are going to have to do some work within the imperial system. So 7.5 by 7.5 inches. So the area of a stone would be 7.5 inches by 7.5 inches. So we can multiply those together and get 56.25 square inches. Okay, now the area to be covered is 1 yard by 1 yard. But we're going to have these two measurements in the same units. So if we look at our formula sheet, 1 yard is 36 inches, and we talked about that yesterday. So if it's 1 yard by 1 yard, that's the same as 36 inches by 36 inches. So this will be 36 inches by 36 inches. We'll multiply those together. First, I'll store that last number into memory slot A. And then I'll go 36 times 36, which is 1,296 square inches. And then the number of stones that are required, again, would be found by dividing. 1,296 square inches is the area to be covered. Each stone is 56.25 square inches. If we divide those, we will have how many are required. And again, I put that 56.25 in memory slot A. So 23 won't quite do it, even though if you round this property be 23 tiles, but you'd have a little piece that isn't covered. So you're going to need 24 tiles here. And that last one will have to be cut. Most of it will be unused, but if you want to cover the entire area, that's how many tiles you would need. Part B says to tile a floor that is 3 meters by 4 meters, how many tiles measuring 30 centimeters by 50 centimeters would you buy? It says add an extra 10% for the number of tiles for the areas that require to be cut. So again, we notice that the area of the floor is in meters, the area of the tiles are in centimeters. They need to be in the same unit, and it doesn't matter which way we do it. I'm going to convert the area of the floor to centimeters. 3 meters would be 300 centimeters. So this first thing is the area of the floor. It'll be 300 centimeters times 400 centimeters because there are 100 centimeters in a meter. And I think if we look on our formula sheet, we will see that. 1 meter is 100 centimeters. Okay, so that's where that comes from. So 300 times 400 would be 120,000 centimeters squared. 3 times 4 is 12, and then you're going to have 4 zeros. So there's the area of the floor. The area of each tile would be 30 centimeters by 50 centimeters. 3 times 5 is 15, and there'll be 2 zeros here. 1,500 centimeters squared. And so again, the number of tiles will be found by dividing. You take the 120,000 and divide by the 1,500. And then it says to add 10% after, so we'll do that after. So 120,000 divided by 1,500, 80 tiles. Now to add 10%, we can multiply by 1.1. The 1 represents 100%. You're going to have all the tiles plus 10% more. That's what the 0.1 represents, 10%. So you can multiply by 0.1 first if you wanted to, just by 0.1, and that would give you 8, which you'd add to the 80. Or we can do it in one step, again, by multiplying by 1.1. The first one refers to 100%, all of the 80. The 0.1 is 0.1 more, or 10% more. Either way, you're going to get 88 tiles with the extra 10%. Okay, so there's that one. Now for the next question, we're using this chart here. Shows the distance required to stop a moving vehicle. It's the sum of the distances traveled during the reaction time. So from the point in time that you see an issue till you actually start applying the brakes, and then the braking time itself. Diagram shows the theoretical stopping distances at various speeds. So you can see that the speeds are in kilometers per hour. The distance traveled during reaction time is in meters. The distance traveled during braking time is in meters. And so then the total distance to stop, is also in meters. So part A says, what factors might affect reaction time and braking distances? Well, road conditions for sure would be one thing that would affect those. Road conditions, is it slippery? Is it wet? Those will affect stopping times. And reaction time would be affected by if someone is a distracted driver. That would definitely affect reaction time. So those are just two things. Part B says, if a vehicle is traveling at 100 kilometers an hour, how much distance is traveled while the brakes are being applied? So 100 kilometers an hour is this one right here. We want the distance traveled while the brakes are being applied. So the first, again, part of the graph, the 20.8 is just the reaction time. The total distance to stop is 85.4. The difference between those two will be the actual distance traveled during braking time, which is what we're asked to find. right? Part B, what is the distance traveled while the brakes are being applied? So that'll be the difference between 101, sorry, 85.4 and 20.8. That's what we need to do for part B. The difference between 85.4 meters and 20.8 meters. Which is 64.6 meters. Part C says, convert 55 miles per hour into kilometers per hour. What is the approximate stopping distance when a vehicle is traveling at this speed in feet? So we have to convert the 55 miles per hour into kilometers per hour because that's how the table is set up. It has speeds in kilometers per hour. So our first step is to convert 55 miles per hour to kilometers per hour by looking and seeing on the formula sheet what the scale factor is. To go from miles to kilometers, 1 mile is 1.609 kilometers. So to convert from miles to kilometers, we multiply by 1.609. And that'll convert it into kilometers. Again, it's 55 times 1.609, which is 88.495 kilometers per hour, which we're going to have to round because our table goes 80 kilometers an hour, 90, 100, and so on. So we're going to have to round that up to 90 kilometers per hour. And you want to know the total stopping distance, which at 90 kilometers an hour, the total stopping distance is 70.7 meters. Right from the chart. But we want to write that in feet. So back to the formula sheet we go. To go from meters to feet, 1 meter is 3.281 feet. So we have to multiply our number by 3.281. And this will convert meters into feet. So 70.7 times 3.281 gives us this many feet, approximately 232 feet. To the nearest foot. Okay. And on the next page, using the same chart. Determine the difference between reaction time distances for speeds of 110 and 120 kilometers in feet. So reaction time at 120 kilometers, the reaction time is 25 meters. And for 110, it's 22.9 meters. So the difference there would be 2.1 meters, which we also want to write in feet. And as we saw just on the last question, to go from meters to feet, we multiply that by 3.281. Right on the formula sheet is where we find that. So approximately 6.9 feet. That's the difference in the distance traveled during reaction time between those two speeds. Part B says convert 90 kilometers an hour into miles per hour. What is the approximate stopping distance for a vehicle traveling at this speed in yards? So this is part B. So 90 kilometers an hour into miles per hour. If we look on our formula sheet again, to go from kilometers to miles, again, the conversion is 0.6214. So we're going to multiply the 90 by 0.6214. So 90 kilometers per hour times 0.6214 is approximately 56 miles per hour. But we want the stopping distance, the approximate stopping distance, and so for that we'll use the 90 kilometers per hour. We see that the total stopping distance is 70.7 meters. So our stopping distance is 70.7 meters. That comes right from the table or the diagram, which we want to convert into yards. We want to go from meters to yards. So if we look on our formula sheet, there is a conversion there. 1 meter is 1.094 yards. So we're going to multiply the number of meters by 1.094. And that'll convert it into yards. So we'll take the 70.7 and we'll multiply by 1.094. So approximately 77 yards if I round to the nearest yard. And I could use the entire decimal, 77.3458. So then this, I guess we don't have to use approximate there because we didn't round anything off. Okay? So, once again, you guys are going to have a quiz on Monday on this stuff. Page 47 to 48, numbers 7, 8, 12. 13A is what you're going to work on, as well as 16. For practice, I will post the solutions to Google Classroom so that you can check your work. I would encourage you to do that, though, because you need to be ready for your quiz on Monday. Also remember that Friday, the 9th of June, which is coming quickly, is the last day to hand in any missed assignments. After that, they will go in as 0. Okay, no excuses. They'll go in as 0. You guys have had lots of warning, lots of time to get working on this stuff, so don't leave it till the end. And when they go in as 0s, your marks will go down. So again, if you're looking on PowerSchool, if there's any blanks, that means you haven't handed that in. It's got to be done. Okay, so you're looking for the blanks in PowerSchool.